everyone, it's actoutgames.com here, and today I am going to be doing a live reaction to the OSIRIS-REx launch. It's actually launching in about 5 minutes from right now where I'm saying this, which is super duper duper exciting. And obviously I went to, and I saw the actual spacecraft, and I learned a whole lot about it, and I'm super excited.
From now until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure.
Okay, so they're about to perform the
You'll hear the
final
team securing Atlas liquid oxygen topping, followed by the call to transfer the Atlas and Centaur stages.
T-minus 4 minutes and counting. 2, 1, mark.
And we're at T-minus 4 minutes and counting.
There's 4 minutes until it launches. There's a timer.
Atlas and Centaur stages will be transferred from ground facility power to internal battery.
They're they're working power now. So there's a countdown here.
At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity.
Okay, this is a lot of science. But there's a timer down there that is saying how long there is until the actual launch. So there's not 5 minutes, there's 3 minutes left. Which is absolutely crazy. I had no idea it was launching so soon. But yeah, I'm super excited. It actually has been a little bit since we went there, but it does not feel like it.
T-minus 3 minutes and counting. A brief look at the Mission Director Center in the Atlas Spacecraft Operations Center.
FTS internal.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away.
What? What do you mean? Okay. Okay. So I'm going to explain what the mission is in 2 minutes. So what it says is this is a
T-minus 2 minutes and counting.
1 minute 59.
But this is a really cool mission, which is they're going to send a spacecraft into space called OSIRIS-REx, and they're going to collect a bunch of debris off of a meteor, and they're going to bring it back for testing, which is really exciting. And we actually don't know much about meteors, which is really cool. So we're able to get stuff and study it. So that's what this mission is doing. I've seen the actual mission. We saw, I got to ask the questions and stuff like that. And it will launch and collect, and then come back. And I don't remember exactly when it's coming back, but it's going to be a few years that it's going to spend in space and collecting stuff. And I'm really excited. I hope there's a good place to sort of stay up to date with what it's doing at the time. So yeah, it's just a really cool mission. I did a video on it. It'll be linked in the doobly-doo, where I actually went to an event here in Colorado, where we actually talked about this mission, and we got to see it, and we got to talk about the scientists that worked on it, which was super duper cool. So it'll be linked in the doobly-doo where you can check that out. And now we are seconds away, so I'm gonna shut up now.
Step 3.
30 seconds.
28. 25.
Status check. Go Atlas.
Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx. Its 7-year mission to boldly go to the asteroid Bennu and back.
Good. Pardon me.
speeds and check the pressures are within 10. Repeat, chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Already 180, injector pressures are good.
This means so much. I don't know where these cameras are coming from, but they look cool. So.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REx has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle hydrates continue to look good.
Yay, that's
This is
good.
the point when the mechanical stress on the rocket reaches its peak
And
because of
booster
the
has
rocket's
proper
velocity and resistance created by the Earth's atmosphere.
Hey, that actually makes sense. Yay. Oh, this is so cool. Okay, so you might see this whole rocket. This is not all of OSIRIS-REx. OSIRIS-REx is actually like it's big, but because it's a rocket ship. But it seems smaller than it looks because almost that whole thing is just fuel to send it up into space, and then I think it's gonna like drop that into a desert somewhere, and then it's just gonna keep going purely based off of inertia, which is really cool. First of all, it's just gonna keep moving because there's nothing there to stop it. So it's really just gonna keep moving until it gets affected by gravity, which is really cool that it's able to do that, and it only needs fuel to be able to get out of the atmosphere, which is just a really cool science thing that I finally just, oh, look at how pretty that looks. Oh my gosh.
Next major event will be SRB jettison, coming up momentarily.
Oh, there it goes.
And you see the solid rocket booster jettison.
There it goes. So yeah, it's just dropping it into the ocean probably.
Vehicle has enabled
And
closed
that's all it
loop.
needed. That's all of the fuel it needed. Like you would
RD-180
think that
engine
it would need to have
continues
that all that
powering
fuel
the
is
Atlas,
to get it
Centaur, and
all the way to
OSIRIS-REx into
venue right back.
space.
But it's not. It's just to get it out of the
Next
it's
major
just
milestone will
to
be
get it out of the
booster
atmosphere.
engine cutoff.
And then it does have to come back. But it's really
4 minutes
cool
and 2
that
seconds
that's
into
all they
flight.
need. And it's just dropping it into the ocean.
Flight level, signatures look good. Current altitude 40 miles, downrange distance 75 miles, current velocity 5,988 miles per hour.
Okay, it's going fast.
Range track looks good.
They have such fancy cameras. I'm kind of jealous that they have cameras that can film
About
that.
1 minute away from Atlas booster engine cutoff.
Already burn well, pump speeds, injector pressures within
So it's a minute
band.
until
Vehicle body rates look good.
look at how pretty that
Vehicle is
is.
now 1/4 of its liftoff weight.
Look how pretty space is. I find space so pretty.
Coming up on our 5G throttle segment momentarily.
It's so cool. This is happening right now.
And we have
Well,
begun
I'm sitting
throttling
here.
to maintain
Something's
5Gs.
being launched into space.
Signatures look good.
So cool. Okay, I'm just a bit giddy. This is actually happening right now.
Boost space cooldown is underway.
Oh, I have simulation. I think. Or maybe status that looks like simulation, but
And begun to throttle to 4.6 Gs in preparation for BECO. Boost space cooldown is complete.
it's saying, I think what they're saying is everything is good, which is
And we have
very
BECO.
exciting
Engine
that this
shutdown
is
looks good.
actually getting into space and everything's
Booster
okay.
engine cutoff confirmed. Standing by after
And we have
spacecraft separation for the Centaur single RL-10C engine to ignite.
We have ignition and full thrust on the RL-10. Coming up on payload frame jettison.
Everything continuing normally. The Centaur engine producing 22,900 pounds of thrust, and it will burn for just over 8 minutes.
Centaur body rates look very good. The steering has been enabled.
And the payload fairing, which was covering OSIRIS-REx, was jettisoned. Everything continuing on the timeline.
Current altitude for Centaur is 101 miles. Downrange distance is 471 miles. Current velocity 12,589 miles per hour. We do have report from the booster performance, and it is basically nominal. Since our PU is currently on the Oxford stop, chamber pressures look good. Ox pump discharge, fuel venturi, and pump speeds all are good.
This is all happening so fast. It's like, it seems like it'll take, oddly, like a lot longer for a spacecraft to get, like, actually get into space and leave the atmosphere and everything. But it's been like 10 minutes since I started.
6 minutes into the flight of OSIRIS-REx.
Perfect timing for them to say that. 6 minutes into the flight, so it launched 6 minutes ago and it's already like into space. And it seems
RL-10
like
continues to perform well.
so
Chamber
much
pressures,
longer
box pump
for a
discharge, and fuel
spacecraft to
venturi
actually
all within expected range.
launch and get into
Since our
space
PU
and
has come off the
start heading on its
Oxford
path. But it just
Body
takes
rates
6
controlling down
minutes,
the
which
middle.
is absolutely crazy.
About 6 minutes left in the
Ready.
burn of the
6
Centaur
minutes in
engine.
the region, which is, it's just
Battery
insane that
voltages
this is
all are stable at this point.
they-
Tank pressures
this
look
is what
good.
they have. That's all it takes. Like, it takes like years and years and years and years to prepare the spacecraft, and then there are
And
6
we have had the
minutes
format change.
for you to
Very
figure out
minor
whether
loss
you
of data during
actually
that.
did it and got it into space or not, which
Seen our
seems
normal
like
thermal
so
conditioning
stressful. I
clearance
can't
on the
imagine what
RCS.
it's like what it's
Flight
like to
temperatures
be
have
one of the
nearly
scientists
warmed
working on
to
this mission,
bottle
because you have spent
temperatures.
years and years of your life working on this one thing, and every little detail, every little test you've ever done is all packed into this 6 minutes. 6 minutes, which is
Once again, you're
so
hearing the voice
short
of United Launch Alliance
for,
Marty
like,
Malinowski.
you having to check and make sure
Following the ascent
every
of the
single
vehicle.
little thing
Making
works
good progress
to make sure
down the
it's
middle of the
able
range.
to get into space. And it's just
And Centaur has begun
crazy
range steering at this point.
to just think about, honestly, that all this happened, like, from me waiting for it to launch, it actually launching, and it now being in space, and the engines are
Current
about to,
altitude,
like, turn off.
139 miles.
This all
Down
happened in
range
12
distance,
minutes.
1,008 miles.
It's
Velocity
12 minutes from when I'm recording this,
13,783 miles
and
per hour.
it's just so insane that it's actually leading up, and I'm really excited. I'm hoping there's some, if there is a really good place to keep up on the mission, there'll be a link in the doobly-doo. If not, then I'm so sorry. I would love for there to be, like, I'm sure there is, like, a really nice place to keep up with what it's doing, like, see where it is and how close it is to its goal. And obviously it's going to take a few years because it has to go, like, really, it has to go, like, past Pluto back. So it's going to go really far and come back. So it's going to take a while, but it's so exciting that this is actually
About 4
happening,
minutes
and
remaining in the burn of the Centaur engine.
I'm actually really excited for what the mission is doing, because it seems like we know so much about everything, but we don't really know too much. So actually, like, we hardly know what meteors are actually made out of. As well as they're doing this because
See the
a lot of meteors still have stuff left behind from the
spacecraft
Big Bang,
traversing
which
out
is
over the
so
Atlantic Ocean.
exciting that we get to learn about how, like,
28.5
the
degree
world
inclination from the
actually
equator.
formed and created and all this stuff just from this one mission, which is so exciting. I think meteors are super duper cool things because they have so much. We hardly know anything about it. It's like our ocean. Like, you'd think we know lots about our ocean. We know all these fish types. We know all of this, but we don't. We don't know that much. We are learning right now, but we don't know that much. And it's the same with things that we, like, a lot of, if you ask me, a few years ago, like, before I was doing all this, like, do you think we know a lot about meteors or asteroids or this? And I'd be like, yeah, I think we know a lot, but we don't, and that's why we're sending this mission out, because we have theories about a lot of things, and a lot of people sort of widely accept these theories, but we don't know much, which is, I'm so excited that they're able to start figuring this out. We're able to start figuring out all this different stuff, like how everything started, and just what meteors are made out of, and why they're here, as well as they're saying they can use this data to stop like, giant meteors, because it's a widely accepted theory that meteors wiped out the dinosaurs, so we're going to try and use this data to stop that from happening to humans, which is super duper cool that we just have this platform and this thing just going on. And I'm super excited for this mission. I'm sure, like, I don't know how old I'll be or how long it will be, but like way later, I'll still be way geeking out of this mission, and I just want to know what data they're gonna collect, what data they're gonna find. We've learned quite a lot about the actual mission and how it's planned to go, but I want to see how it actually goes and like how it collects all this different stuff and how all this happens. Like, it's amazing, and this mission is so cool, and I was so lucky to be able to actually go see the spacecraft and be able to just be able to see the spacecraft and be able to talk to the scientists and be able to just do so much and learn so much about the mission. Like, I'm so lucky to be able to have done that, as well as so lucky to be able to watch, to actually watch it take off, and it's so crazy and so exciting. Like, as you can tell, I'm very excited about this mission. There'll be a link in the description to where you can check out the OSIRIS-REx webpage, and you can learn a lot more about it, which I'm hoping you guys will check it out because it's such a cool mission. If you haven't already seen the video that I did there, there's still so much to learn, and there's still so much to discover just on the webpage, and I'm sure you could do lots of in-depth learning, like what it's made out of and how they did it, because I would personally love to be able to work on a spacecraft, like even in the slightest way, because I just have such a fascination with such a fascination with space, because I find it so cool, and I love learning about space. Like, I love the ocean, I love space, because they're deep things that we don't know much about, and they have such cool stuff. Like, I said for a while that I really wanted to be a marine biologist, because we didn't know anything about the ocean, and we still don't. Like, we know about, like, what we're brave enough to go and check out, but like down on the ocean floors, there's really scary stuff, and we don't want to go there, so we don't know much about it. So it's super exciting that that's actually a thing we can do. Like, we can go out to space, because space is so cool too, because there's just so much of it. Like, at some point we will have known all that's in our ocean, but like, space is probably infinite. There's just, you can never stop exploring. After the release of No Man's Sky, all these sci-fi things make it so interesting, because like, in the future we could be living on these planets, and we could be able to explore planets and be able to learn so much about everything else, and it's so exciting. I think this is a huge stepping stone, because we're going to be learning so much for meteors and space is super duper cool. I'm not sure what happened to the video here. It's been stuck for a while. I'll try and refresh it, but I've just been talking, so whatever. It's just like, is it? Okay, there it goes. Okay, yay! It's got stuck. Or I think it froze. But yeah, it's going, like, it's just so crazy that right now I am watching, and I have seen the actual spacecraft. So it's going to space, and it's going to collect this data from a meteor. And it's just so crazy and so cool, and it's just so cool.
Center tank pressures, storage bottles, batteries are all
stable. Yay! It's stable. And it's just so crazy to think about that this is actually, like, going on right now. Like, to me, a lot of things that I watch are playbacks, something that happened in the past. Like, YouTube, when you're watching this isn't happening. When you're watching this video, it's not happening right now. It happened earlier. But when I'm watching this, it's happening right this second, which is so cool. And I love the idea that there's live streams of this, and there's almost always been, but just being able to watch one is so cool. And I just love it so much, and I'm so lucky. As I said, like, a few times before, there are links in the doobly-doo to learn more about this mission. It's super exciting, and I love it a whole lot. Please press the subscribe button if you want to keep up more with me and all my science adventures. I think this was such a cool one, and I'm so fortunate to be able to have actually done it. So yeah, thank you for watching, and I'll see you tomorrow. Bye!